Good afternoon, everyone. Happy Friday. Hopefully you were able to get through most of the material yesterday by helping each other out in class. Today what we're going to be doing is finishing up section 5.2. We're going to continue to be dividing radical expressions, but this is part 3. And what we need to focus on today is very, very specific. We need to be able to remove radicals from denominators that are binomials. We need to rationalize binomial denominators. So, as a warm-up, just to get our brains in gear, if I gave you something like 4 over root 6 yesterday and I said simplify, you might look at it and go, well, 4 is a coefficient, root 6 is a radical, I can't divide them. Root 6 cannot be simplified because there's no perfect square that divides into 6. But one of the important aspects of yesterday's work is knowing that you have to rationalize all denominators. So what we would do here is multiply top and bottom by root 6, get 4 root 6 on the top, and get 6 on the bottom. We get 6 in the denominator because root 6 times root 6 is 6. Now what we have are a couple of coefficients. This 4 is a coefficient, and so is that 6. And 4 divided by 6 simplifies to 2 divided by 3. And that's it. That would be our answer, 2 root 6 over 3. So in that warm-up, you multiply the top and the bottom of the expression by root 6 in order to rationalize the denominator. If the denominator is a binomial, so I'll give you an example here before we go on. If we take a look at, well, any of these ones we're working on today, example 1 has a denominator of 2 plus root 3. That's a binomial. There's 2 terms. Example 2, the denominator is the square root of 8z minus 3. Well, that's a binomial. And if you take a look at example 3 and 4, you will discover they are binomials as well. In order to rationalize a binomial radical, you need to multiply the top and the bottom by what's called the conjugate of that binomial. Now, what is a conjugate? An example of 2 conjugates would be 4 root 6 minus root 3 and 4 root 6 plus root 3. So conjugates have a form where one of the binomials is a minus b and the other is a plus b. They don't have to contain radicals. X minus 7 and x plus 7 are conjugates. 5 minus 8 and 5 plus 8 are conjugates. And it's important for you to note before we go on that they are conjugates of each other. It doesn't matter the order that I write these two things in, they are both conjugates of each other. So we are asked in question 1 to simplify the product of those 2 conjugates. And I realize I don't know how on earth this happened, but when you look at your handout, what printed on the photocopier is almost on the edge of gibberish. So I want you to take a minute and fix what's printed out on page 9 of your handout where it says question 1. All right, so what we are asked to do is multiply these 2 conjugates together. Well, they're binomials, so what we are going to do is use the FOIL rule. First, outer, inner, and last. So first means we're going to multiply this term by this term. So we're going to get 4 root 6 times 4 root 6. Well, we can multiply 4 and 4 because they are coefficients. And we can multiply root 6 and root 6 to get 6. In terms of my outer would be the product of this term and this term, so it's 4 root 6 times root 3, which will give me 4 root 18. I can multiply the root 6 by the root 3 to get root 18. My inner is the product of these two, and that's going to give us negative root 3 times 4 root 6. Well, we're going to have negative 4 for a coefficient, and root 3 times root 6 is root 18. And our last is the product of this term and this term, which is negative root 3 times positive root 3, which will give us negative 3. Root 3 times root 3 is 3. What's interesting here is that your outer and inner reduce to 0. And you're left with 16 times 6 minus 3. And 16 times 6 is 96 minus 3 gives you 93. So we are asked a further question here. What do you notice about the product of the two irrational conjugates? I want to go back and point out to you that this that I'm going to highlight in blue is an irrational number. And this that I'm going to highlight in green is an irrational number. But the product of them is 93. And 93 is rational. There's a reason for that I will get to in a minute, I think. But the bottom line is a plus b times a minus b will always give you a rational number. And the reason is quite simple. It's because a plus b times a minus b, when you FOIL it out, gives you a squared minus ab plus ab minus b squared, which gives you a squared minus b squared. If there was a square root in a, when you square it right here, that square root will go away. If there was a square root in b, when you square b, it will go away. So when you multiply conjugates, this is the way I like to describe it, you do not have to FOIL when you multiply conjugates. What you can do is just FLA. What I mean by that is you can simply take the first and the last because the outer and inner are always going to reduce to 0. Let's put this into practice now. How do we rationalize this denominator? Well, if we have 5 over 2 plus root 3, I know that if I multiply a binomial that contains a radical by the conjugate of the binomial, that the radicals will go away in the denominator. So if the denominator is 2 plus root 3, the conjugate of 2 plus root 3 is 2 minus root 3. So what do we get on the top? We get 5 times 2 minus root 3. And I don't think there's really anything to be gained by us multiplying that 5 into the 2 minus root 3. On the bottom, we end up with 4 minus 3. Let me walk you through that. We have 2 plus root 3 times 2 minus root 3. If I FOIL this out, I get 2 times 2. I get 2 times negative root 3, which is negative 2 root 3. I get 3 root 3 rather times 2, which is positive 2 root 3. And then my last is this product. I get minus root 3 times root 3, which is minus 3. Again, this outer and inner reduce to nothing, so I'm left with 4 minus 3. This is the answer. 5 times 2 minus root 3 is the answer, because 4 minus 3 is 1. I don't think we need to write over 1. If you did, it wouldn't be wrong. But I would rather you just wrote 5 times 2 minus root 3. So 5 times 2 minus root 3 is the answer. If you choose to multiply that 5 through and write 10 minus 5 root 3, I don't have any objection to that. That is also correct. Let's try another one. 12z over root of 8z minus 3. I think it's always a good idea to rewrite these before you do anything. Usually what is printed out in your notes or handouts is pretty small compared to how people write. So I'm rewriting this. I want you to notice that this square root symbol extends past the z, so the z is included. I'm going to multiply top and bottom of this by the conjugate of the bottom, which is the square root of 18z plus 3. So what do I get on the top? Again, everybody, there will come a time where I will explain to you why this is beneficial. But I wouldn't multiply that 12z through. On the bottom, we're going to get 8z minus 9. Be very careful here. We know that when you take root 8z minus 3 times root 8z plus 3, there's no need to do outer and inner. All you have to do is do first root 8z times root 8z is 8z, and last 3 times negative 3 is negative 9. It's a little bit different. I want to go back to the previous question because the conjugates in the previous question had root 3 times root 3, which gives you 3. In this question, we have 3 times 3, not root 3 times root 3. So you get 9. Just want to rewrite what I have on the left-hand side. It looks a little cluttered. We have 12z. We have 12z times the square root of 18z plus 3. And we're pretty much done except for the fact that root 18z can be simplified because root 18z is root 3 times 3 times 2 times z. So this 3 can go outside, and we can have 12z, and then we'll have 3 root 2z plus 3 over 8z minus 9. There is one more thing we can do here, and I'd like to kind of say, well, let's not worry about it, but this is Math 20-1. We can't just disregard the pieces that we don't want to talk about. When you take a look at this binomial, there is a common factor of 3 in it. That binomial, we can take a 3 out and have root 2z plus 1, and then we can take this 3 and marry it to the 12z out in front. In other words, multiply it together. So to show that to you, we have 12z, and then we have times 3, which we factored out of that binomial, times root 2z plus 1, and it's over 8z minus 9. All I'm saying is if you want to, we can multiply these together and write 36z times root 2z plus 1 over 8z minus 9. And that is our answer. Next one, 12 over root 6p minus 3. I want you to notice that in this case, that square root sign, if you look very carefully, does not extend past the p. The number is the only thing that's in the radical, minus 3. So we're going to multiply the top and the bottom of this by the conjugate of the bottom, which would be the square root of 6 times p plus 3 again. Let's leave the top in factored form. We'll leave the 12 out. Again, sooner or later we're going to see why that's a good thing, but again, I kind of fall back on this idea. If you multiply that 12 in, what good does it do? It doesn't help you in any way. It doesn't make the expression any simpler. It just creates a bunch of bigger numbers. On the bottom, we're going to have 6p squared minus 9. Why is that? Because we're taking root 6p plus, well, I guess it's minus 3 first, times root 6p plus 3. So your first is the product of these, root 6 times root 6, and then p times p is p squared. Your last is negative 9. Now, I just mentioned a minute ago, sooner or later we're going to see a reason why you want to leave that 12 out in front, and we're going to see it right now. Because I can factor a 3 out of the denominator and have 2p squared minus 3. And in the numerator I have 12 times root 6p plus 3. Well, I can reduce the 12 over the 3 down because they're both factors. Twelve over 3 is 4, so we get 4 times that root 6p plus 3 over 2p squared minus 3. And that's our answer. I might have said this earlier, this lesson is not a long lesson, but it's pretty deep. There's a lot going on here. I think we're on the last one, which is a beast. So let's rewrite this first. It's 3 root 6 plus root 5 over 2 root 6 minus 3 root 5. Now don't do anything crazy here. You can't do something like this. That's out of line. You can only cancel something. Remember what I've tried to instill in you. You can only cancel something if it's a factor on the top and the bottom. And that means it has to be in its own set of brackets being multiplied by everything else. And those 2 root 5s are not. And neither are the 2 root 6s. And neither are the 2 3s. We cannot cancel anything. All we can do here is multiply top and bottom by the conjugate of the bottom. It's always the conjugate of the bottom. So I'm multiplying top and bottom by 2 root 6 plus 3 root 5. So we know what's going to happen on the bottom. What's going to happen on the bottom is you can just take first and last because the outer and inner cancel. That's why we're using conjugates, because that's what happens. So I need to multiply this 2 root 6 by the 2 root 6. Well, 2 times 2 is 4. Root 6 times root 6 is 6. I also need to multiply the negative 3 root 5 by the 3 root 5. Well, the negative 3 times the 3 is negative 9, and root 5 times root 5 is 5. But then on the top, I have to FOIL it. I need to FOIL this out. When I go back and look at what I told you about leaving this 12 where it is, only do that if it's a number. But if you're dealing with something like on the top here, 3 root 6 plus root 5 times 2 root 6 plus 3 root 5, you need to FOIL it out. So I need to, and I'm going to run out of highlighting colors here, so I'm going to move some things around. First will be the product of these two. So that's my first. 3 root 6 times 2 root 6. 3 times 2 is 6. Root 6 times root 6 is also 6. Now I'm going to do outer, which means I have to multiply 3 root 6 by 3 root 5. So 3 root 6 times 3 root 5, 3 times 3 is 9. Root 6 times root 5 is root 30. Now I need to multiply my inner, which are these two underlined terms. Root 5 times 2 root 6. Well, you can think of there being a 1 in front of the root 5. 1 times 2 is 2. Root 5 times root 6 is root 30. And finally, I multiply my last, which is 1 root 5 times 3 root 5. 1 times 3 is 3. And then root 5 times root 5 is 5. So what do I get? On the top, I have 36 plus 11 root 30, and then I have plus 15. On the bottom, I have 24 minus 45, I believe. Let me just double check that. Yep. So what do I get? Let's see. 36 plus 15 is 51. Plus 11 root 30 over 24 minus 45, which I believe is negative 21. Pretty sure, but you know how it goes. If I can get my calculator on first, there we go. 24 minus 45. 36 plus 15, I'm pretty sure, but I want to make double sure is 51. And I would say that's good enough. What we have there is the answer. If we want to, and you don't want to do this all the time, but this is the last example, so let's give it a crack. I could figure out what this original expression is equal to. I'm going to require a lot of bracket work here or storage in my memory of the calculator. 3 root 6 close brackets plus root 5. I need to divide that by, I'm going to put this in brackets on the bottom, bracket 2 root 6 minus 3 root 5. The original expression has a value of approximately 5.29 and it's negative. If I take a look at what I got for an answer, which is to the right of my calculator, I have 51 plus 11 root 30. And I need to divide that by negative 21. Jackpot. So the answer is 51 plus 11 root 30 over 21. Parting thought here. I know you know that I don't like putting a negative in the denominator. I'm not sure I would want to put this negative in the numerator because then that would make both terms negative. This is a rare case where I might want to put it out in front of the whole fraction and just write negative 51 plus 11 root 30 over positive 21. Alternatively, you could do this. You could do that. You could multiply it through, but I dislike that negative in the denominator. So lesson is not very long that we just went through, just 4 examples, but you need to practice this. You need to, as my dad would say, buckle down and get to work on this and get a lot of good practice in. Just like yesterday, there is a set of questions that I've typed up and put in your handout. That's what you should be working on for Monday. Come to class Monday prepared to ask questions from the last 2 lessons, from yesterday's lesson and from today's lesson. And if we have to have a day Monday where we're just practicing and getting more and more practice and help with this, that's fine. We can make up the time elsewhere. And I know it's difficult when I'm not there, but I had to be away. I couldn't avoid it. So get to work, help each other out, and we will see you guys on Monday. Have a great weekend. Take care.